All right, so this is section 5 of chapter 3, in which we will consider other aspects of measurement, including multiple measurements, sensitivity of measurements and range effects, artifacts such as bias, and the selection of the appropriate measurement procedure. All right, so measurements, as we've been talking about, come in many shapes and sizes, many varieties, many flavors, each one having its own advantages and disadvantages. For example, again, if you're measuring fear, you might use self-report, or maybe you use a physiological measure like heart rate or skin conductance, perspiration. And again, each one will have its own pros and cons. So one thing you might do, given the fact that each measurement has limitations, is to use multiple measures when studying a single construct. And by using multiple measures, you might get a more complete and holistic understanding of that construct, especially if the construct is pretty complicated and multidimensional in nature. Also, using multiple measures increases the confidence in the validity of the measurements. Confidence that you are actually measuring what you think you are measuring. However, there are also disadvantages and challenges. For example, the statistical analysis becomes much more complicated when you have multiple measures. And also, what happens if your measures don't agree with each other? Let's say you have a measure of fear and, self-report says that the person is afraid, but the physiological measures do not show any evidence of fear. How do you interpret potential disagreements or discrepancies between your measures? So you can introduce, more complexities into the study. One approach that people have used is to combine multiple measures into a single score. So you're working with one value that is a composite of multiple measures. Okay, sensitivity and range effects. So sensitivity, this is the idea that the measurement tools that you choose should be able to detect the expected direction and magnitude of changes in the variable that you care to measure. So to simplify this statement, your measurement technique has to be sensitive enough to detect the changes that you care to detect. For example, by analogy, take a scale that tells you the weight of an object. Most scales are pretty sensitive, where they can tell the difference down to maybe 1 pound or even less. So if you put an object on a scale that weighs 50 pounds and you add another pound, you'll see that difference. You will see the value go up from 50 pounds to 51 pounds. But imagine you have a scale that's not very sensitive, that detects changes of 10 pounds or more, but not less. Then if you add 1 pound to your box, to your object, you would not see any change. You would not be able to detect that change in your instrument because it's not sensitive enough. And so same thing goes in the instruments that are used by psychologists. You have to make sure that your measurement technique is sensitive enough to detect the changes that you may expect from your variable. So range effects occur when scores cluster at one end of the measurement scale. And now you can't really detect the changes that you care about. So here's an example. Let's suppose you want to compare math performance of kids in different states. So let's say you take a sample of kids from every state and you give them a math exam that you came up with. Well, it's important that the difficulty of that math exam be just right. It can't be too difficult and it can't be too easy. Because imagine if the exam is way too difficult. Like you have, questions that only mathematicians would be able to answer. And all your kids get like 0. They all fail completely. And as a consequence, you don't see any differences between the states because everybody has a 0. Everybody does very, very poorly. That's called floor effects. Floor effects when scores cluster at the low end of the scale. Now, conversely, you can imagine the opposite problem. Imagine you give a test that's way too simple. It's like 2 plus 2, right? And everyone across all the states does really well, gets 100% or something close to it. And again, you can't see any differences because everybody did too well. The test was too easy. And that's called ceiling effects, when scores cluster at the high end of the scale. And so again, you have to design a math test, the difficulty of which is just right, is sensitive to detect the changes, the differences that may exist between the children in these different states. Okay, so avoiding range effects. So you want to pre-test the measurement procedure with a representative sample to make sure it's sensitive enough before you run the full study. That's one approach. And 2, again, ensure that the measurement is appropriate for the target group. So in our example, if you're testing the math ability of young kids, you have to make sure the difficulty of the exam is commensurate to the expected math abilities and aptitudes of children in that age group. Okay, artifacts. Artifacts are defined as external factors that can influence or distort your measurements. And in doing so, they threaten both the validity and the reliability of your measures. So we'll consider 2 categories of artifacts. One is experimenter bias, and this is when the behavior of the experimenter affects the behavior of the participant in the study in a way that changes or contaminates what you are measuring. And 2 is called participant reactivity, and this is when the awareness that somebody is in a study can change the way that they respond, and they may respond in ways that are sort of inauthentic, which can also contaminate your results and their interpretations. Okay, so experimenter bias, as we've mentioned in the previous slide, this occurs when a researcher, right, the scientist conducting the study, unconsciously, unintentionally, inadvertently influences the behavior of a participant by their own actions or by their own expectations. And this can occur in many different ways. So for example, paralinguistic cues, the tone of voice with which a scientist speaks to the participant can in principle affect their behavior. Kinesthetic cues, body language, can also affect somebody's behavior. Verbal reinforcement, how you respond to a participant as an experimenter. And also misjudgment or inaccurate recording of data can also take place and also obviously affect the results of a study. And so anytime an experimenter behaves a certain way towards a participant or a group of participants, you can create these artifacts. So imagine you have two groups of participants, and the scientist is friendly with one of the groups, maybe because they had dinner or lunch, and maybe is rude with a different group because maybe the scientist is hungry on that day or just in a bad mood. And you can imagine that this can influence the way that people behave in these groups and the measurements that you ultimately collect with these groups. Okay, so let's talk about ways of reducing experimenter bias. So one way is to standardize or automate the procedures involved with the experiment. So for example, when giving instructions, you might write down a script that all experimenters have to read to the participant. And this way, all participants hear the same exact instructions, the same words in the same order. That, however, doesn't address other sources of bias. For example, body language or tone of voice, which may differ between different people administering the experiment, or within the same person at different points in time. So to deal with this issue, another option is to record someone reading the instructions or give the participants a handout. In this way, everyone has the same experience and is treated the same way leading into the study. So another approach is the technique of blinding. Now, this is very common in clinical research. So if you're testing the efficacy of a drug, let's say, you typically want to use a placebo group, and the gold standard is to use what is called a double-blind procedure, where neither the participant nor the experimenter knows who got the placebo and who got the drug. Now, in a regular psychology experiment, a single blind procedure is when the researcher or the assistant who's conducting the study doesn't know the expected results, and thus will not be able to influence the participant by their outward behavior or demeanor. A double-blind approach would entail neither the experimenter nor the participant knowing the results of the study or who is assigned to which group if the experiment involves assignment to different groups. So another problem, which has the potential to influence the data and introduce all kinds of artifacts, is what is known as demand characteristics and reactivity. So in psychology, research tends to be conducted on living things, living beings. And one property of living things is that they are active and also reactive, meaning that they respond to their environment. And this is especially true of people, for whom different environments will elicit different behaviors, as will people's knowledge and assumptions about what is happening in their environments. So, for example, we all understand that people will behave differently when they know that they're being observed. If you know you're being watched, if you know your actions are being recorded and analyzed, you might behave differently than if you believe that you are completely alone. And when people are being watched, sometimes we act in ways that are less authentic. We become like actors on a stage, playing different roles. So this gets at the idea of reactivity. When people react or behave differently when they know that they are being observed. Now, more specifically, a research setting is a particular environment that contains all kinds of cues. And these cues may create, in the mind of the participant, all kinds of expectations regarding what behaviors are expected and desired in this particular setting. And these are called demand characteristics. So for example, some participants may try to figure out the purpose of the study and adjust their behavior accordingly. They may try to be a good subject, for example, and produce behaviors that they think will make the experimenter happy. Now, this is a problem to the extent that it elicits behaviors that are unnatural. I mean, laboratory environments are already settings that are quite unnatural. It makes matters even worse if participants begin acting in ways that they otherwise would not act in. So psychologists have identified a number of roles that participants might fall into when running in your study. So first of all, there's the good subject role, which we alluded to. And this is when a participant tries to confirm the researcher's expected results or what they believe the expected results are or ought to be. And this is, of course, a problem because it is inauthentic. And it isn't clear the extent to which your results are driven by this role that somebody may be playing in your study. All right, next you have the negativistic role. And this is when participants try to sabotage your study or expected findings. Maybe they are irritated from having to run in your study, even though they presumably agree to it. And some people just may be difficult to deal with for any number of reasons. Maybe they woke up on the wrong side of the bed and are taking it out on you and your study. Okay, and then next you have the apprehensive role. This is when people try to respond in a way that is socially desirable. These people are concerned about their performance. They are concerned about being judged. And they want to present themselves in the best possible light. So a person playing this role will try to respond in ways they believe to be socially acceptable and desirable. So imagine a person in this role answering a questionnaire about maybe how often they give to charity or if they've ever cheated on their spouse. It is possible the answers they give are dishonest, partially or completely. They may give an answer that they believe society will approve as opposed to the true answer, and obviously it goes without saying that this is a problem. And finally, the faithful role is when participants try very hard to follow all instructions to the letter of the law, either because they really care about good science, or maybe they just don't care so much about your study and what you're trying to explore. And these subjects are probably these are the ones that you want. These are the participants that will introduce the fewest number of artifacts and confounds into your study. Okay, so what are some methods for reducing participant reactivity? So one approach is to adopt the method of natural observation or field studies. And this entails observing people in their natural environments without them knowing that they're being observed. And this will reduce some of the problems that we discussed above. But of course, there are many limitations to this approach. For example, these observations can only happen in public areas where there's no expectation of privacy. You can't set up hidden cameras in people's houses without them knowing, obviously. And secondly, observation does not allow you to manipulate any variables as you might in a laboratory setting. And later in the course, we'll talk about the importance of manipulating variables in a scientific experiment. Now, another approach is deception. And this is where you do everything you can to try and conceal the true purpose of your study. This way, participants don't know what is expected of them or what results you are trying to get. And in some situations, you have to conceal the true purpose of the study, or the study will not work. And in the next chapter, we'll talk more about deception in the context of ethics, because it does raise a number of ethical concerns. You are lying to your participants. Okay. The third approach is to assure confidentiality. So, for example, if you're having people fill out a survey or a questionnaire, and if you're asking people to potentially reveal sensitive or controversial aspects of themselves, maybe attitudes or beliefs that society may deem socially unacceptable, then you really have to assure people that their answers will remain confidential, or otherwise they're going to lie to you. And finally, it's important to take a moment to sit down with the person and tell them that their participation in this study really matters, and underscore the importance of honesty and authenticity in the context of your ability to collect quality data and to do good science with their help. And finally, just some tips or heuristics for selecting a measurement procedure. So one, review the past research involving the variables or constructs that you are interested in exploring in your study. Next, examine and compare different measurement options for the specific research question that you are exploring. Consider sensitivity levels appropriate for detecting expected individual and group differences. So recall our discussion about ceiling effects and floor effects and the importance of sensitivity. And finally, decide on the appropriate scale of measurement, whether it's nominal, ordinal, interval, or ratio, for making the appropriate conclusions in your study.